Welcome back, everyone. Today is for day 2. We're going to be looking at third angle theorem and then just going through some proofs and practicing with those. So the third angle theorem states that if we know that these angles are congruent and it's given that these angles are congruent, then it's an implied that that third angle will be congruent to itself. So we want to use the third angle theorem to solve problems. So in this example, let's look at the problem. It says a drawing of the tower roof is comprised of congruent triangles all converging at a point at the top. So if triangle IJK, so again here we have IJK, that's that front face, is congruent to IKL, which is the side face here, and the measure of angle IJK is equal to 72, find the measure of JHI. So sometimes it might be helpful to just sketch this out and kind of get a picture of what it would look like. So here we have our first frontal side. This is a J, this is an I, and we have the K. And it tells us that J, with this angle here, that's IJK, is equal to 72 degrees. So if we were to take a look at the corresponding part triangle over here, it also has I, but now this is K, and this is L. So they want us to state what we know about angle I. Okay, so it appears that, first of all, that they're congruent, and they appear to be isosceles here. So if this side is congruent, then these two are congruent if this is also 72. So if that's 72, the measure of angle I has to be by the triangle sum theorem, 180 minus 72 plus 72. Turns out that that comes out to be 36 degrees. Alright, this is the next example. I would like you to press pause, kind of think about this, and then we'll go over it. Alright, so I'll just kind of sketch some things out here, and we know by the third angle theorem that this measure of this angle here is going to equal what's ever left over from 90, or sorry, what's left over from 180. And since we know that this is appears to be isosceles according to what they're telling us, that we'll get our answer when we take 180 minus 47.5 plus 47.5. When we work all that out, we get let's see, 85. Okay, I know proofs are not everybody's favorite thing. I'm just trying to help you to think about strategies to be able to solve them. So anytime you have a proof, the first thing you're going to want to do is to diagram what you know. So in this problem, it tells us that angle L and angle P are congruent. So they have already marked that. So that's telling us these are congruent. It's also telling us that line LM and PO are congruent. So that's this side here. And we also know that LN is congruent to PN. And also that this here side is congruent to this side. What we want to do is to be able to say that the triangles are congruent. Okay, so that's going to be our last statement. And we've talked about how in your first statement you just take everything that was given and write that down, and you write the reason that that was given. Then you try to find angle relationships. So we have found that if we can prove that two angles and all the sides are congruent, then the two shapes are congruent, because the third angle theorem will say that we know that it's going to be congruent. So we have to be able to try to prove something about one of the angles. Okay, so they give us a hint here. So angle N here and angle N in this direction. Okay, so think back to what's the relationship between two angles where these two things are congruent. Well, the definition right here is these are related because they are vertical angles. Alright, so since we know that that we have the two angles, now we can say something about the third angle. Since we know that the two angles are congruent, the only thing left to do is to prove something about the M angle and the L angle. So since we have the two things, the two other angles already known, we can just state that angle, let's go LM, and remember order matters. So if we're going to start with L, we need to start with P on this side. So that would be PON, if then those are congruent. So the reason here is we have that this is the definition of a congruent polygon. Remember we saw in the last video that all parts must be congruent. And in upcoming lessons we're going to learn that there's some shortcuts that mathematicians have found out. So let's take a look at the next one. This is the last one. So here we have something that's already been proven. We just need to figure out what is this missing step here. So let's work through this. So QN is congruent to OP, which is this side here, and QP, which is this side, is congruent to ON. So this one is kind of a new thing for us. They share a side. So if that's the case, you're always going to use this reasoning that when you have the same thing, it's just reflexive. It's reflecting through the mirror. All right, the last, step 3 is we are given that angle Q and angle O are congruent. That's here and here. And that angle P here, N, P, I think it's underneath here. So that we have this angle here is congruent to PNO. So PNO, these two are congruent. Alright, so we have here that we have all of the sides. We have two angles. So the last thing we would need is the third angle theorem.